Welcome, my friends, to this presentation of the metrics theme in the Software Center. I'm Miroslav, and I'll show you a bit of activities of what we're doing in our project. First of all, the vision and mission of the project is that we would like to support the collaborating partners in increasing their market and technology leadership. As simple as that, we would like them to be better, faster, ahead of their competitors. That means that we are constantly increasing their performance in different ways, mostly by helping them measuring things. And as you see on the picture, I mean, the ultimate goal is that we basically do a barbecue, or the machines do a barbecue for us. Focus areas of the metrics project are quite diverse. We do anything from software source code analysis, data analytics, data visualization, machine learning for software engineering. We look into requirements quality, the measurement infrastructure, measurement as a service, and diverse technologies. As you see on the pictures here, we have the upper side of the picture, which is a simple dashboard showing one of the companies how fast they are, or in this case how slow they are in software integration and software reviews. In the middle you show an example of a dashboard which have been produced by our team, quite many, and it shows the ability of the project teams to handle defects. And in the last case you show an explanation of a decision tree showing how a machine learning algorithm can prioritize defect on the fly when they come in two of our companies. Our collaboration model is based on a known approach called action research, where we form a reference group together with stakeholders. We work with the stakeholders, we go into the company, sit very often on company premises, analyze their data, have access to the computers and the code of the company, don't take it out from there, and everything we produce goes both into knowledge, learning and theories, as you would say, academic papers, but also quite many times into the actual products, the processes, changes in ways of working, changes in resource allocation, new tools, and in many cases also open source tools. The projects which we have is that we have a few metrics projects and a few projects that are part associated. We have the metrics projects that I will talk about, we have the stakeholders communication project, and we have a develop project that are running right now. We are about 15 researchers involved in those projects and equally many industry collaborators. And we have had a number of projects that are already concluded. In a metrics project, the goal of that project is to help the companies become faster by providing them with the right metrics to optimize towards. In the current state of the art, what we are working in the project is the automating coding reviews. So for those software development teams who are producing code in continuous integration and they have to do a manual review, what we do is we provide them with the suggestions of which parts of the code should be reviewed and potentially what kind of problems they could expect in that piece of the code. This helps them to become over 10 times faster in reviews. We're talking about time decrease from weeks to minutes or hours, depending on the cases. And it for us, it's a fantastic playground to play around with technologies of deep learning, language understanding, model-based analysis, and of course visualization of software. How it works is that we do it completely automatically. We take data that the companies already produce in tools like Gerrit. We export that data into big databases. We create feature vectors from the software code. We create feature vectors based on sentiment analysis. We put them together. We can recognize good and bad parts of the code, and then we use different types of machine learning algorithms to analyze new parts of the code, new code for that. Of course, depending on the code, depending on the company, test cases, this workflow when it comes to classifiers changes a bit, but majority of the work is actually the same. That helps the companies to become better, and what we provide them with is minimum viable products. With the prototypes, we set them up on the company premises and we observe how things are working out. As you see in the results, we are pretty good in recognizing lines of code that require review. On the right hand side you see a diagram which shows the percentage of correctly identified lines of code that violate certain coding guidelines, which are in many cases close to 100%. We also recognize the cases when the machine learning doesn't really work for the companies. For example, when we train the classifier on a legacy code and then we apply that classifier on new code. And by new code, I mean code that has been developed by the same company, by the same team, but 5 to 10 years later. So the technologies have changed, the ways of working have changed, the coding guidelines have evolved, the understanding of the code have evolved, and also the code base have evolved together with the team. What we also do is we create a metric portfolio, which is a huge database of different types of metrics that companies can use in different contexts. For example, if they want to measure products, we have metrics that relate to maintenance of the product, to quality, to security. We have metrics catalog that related to design, for example, how to measure the cloud environment, how to measure the architecture, complexity of the software, size, in different ways. We also have metrics in the area of business, organizational performance, and project understanding. We provide those kind of metrics for the companies in order to understand how to become faster and what kind of measurements they could use. What we also do is we apply those things in real life, and as you see, these are examples of few deliverables where the ultimate goal is a gadget from a few years back where we showed how many defects a company would have in specific weeks, together with prediction models with confidence intervals, so that the quality managers within the company can understand how well or not so well our predictions are. We also could do it on a much larger scale, on a monthly level, showing the companies how the entire release would basically fall out in terms of software quality or testing. These kind of gadgets are quite powerful tool for the quality managers to move into the organization, make changes. So if you, in the lower case of this diagram, what we have observed is that the predictions were actually not very good, not because the prediction model was bad, but because the quality manager, when he looked at this together with the project manager, they decided to change their resource allocation and change the process so that, as you see, the last project looks a bit differently than the previous one, just because of the changes they made based on those predictions. We also use our technology to prioritize different things. So here we take a look at, for instance, test prioritization. We take a look at how do we optimize test suites. So every company that we work with doesn't have time to work with full test scope every day. So they do full test scope on a weekly basis, for example, during the weekend. Then they do a limited test scope every build. And what they also do is that they do a bit bigger scope every day. And what they would like to do is they would like to actually avoid the situation when they have executed a test case, fix a defect, and then got the same test case execution negative again after that, or get a test case in a weekly test suite that has not been executed during the week and that has been failed. They would like to get this feedback not on a Sunday, but they would like to get that feedback directly after the scope, the checking. But thanks to our techniques, as you see, what we did is we could decrease the amount of test cases quite a lot. We could speed up software development technology. We could reduce and extend test cases depending on the kind of scenarios the company want to have. But by the end of the day, what we were able to show is we were able to decrease the time that is needed for software testing by the factor of 5 in certain cases. What we also do is work with requirements quality. This is an example of a tool that has been implemented in one of the companies that one of our PhD students looked at and created a model of how to assess whether a specific requirement is good or bad. And by good or bad here we mean the requirement that is unambiguous, that is understandable, that is testable, and so on. We also, as you see, there are a few of the requirements that are actually not really of good quality, that have to be fixed. And they even call it VART's Requirements Quality Index in the end of the day. We all the time look at different ways of using software measurements, both looking at the AI for software engineering, what kind of metrics we could use to create prediction models. We work quite a lot with machine reasoning, so instead of just making a prediction, also trying to provide a recommendation, just like in the source code, not only making a prediction which line of code is of a bad quality, but also what is wrong with that particular line of code. We strive towards something that we call autonomous artificial intelligence based measurement, which is a measurement that can automatically adjust based on the changes in their environment. We have worked with things like self-healing and measurement systems in the past that allow us to, that are mechanism and platform for doing those kind of things. Then we have projects like Develop Project, which are done together with Volvo Cars. In this particular project, we utilize machine learning to make cars a bit safer. What we do is we create autoencoders and put those autoencoders in safety cages in modern cars to understand how well a car can recognize specific driving situation. Now, what we have found is that in many cases in the automotive industry, these kind of approaches, what the neural network actually learns is not what we learn. So the neural network quite often doesn't learn objects like a car, but it learns colors or saturation of a picture, meaning that in particular cases it could be a very bad scenario. For example, car not recognizing an anomaly, or quite often cars switching into the safe mode where it asks the driver to take over, which is not very optimal for autonomous driving scenarios. We also have projects in stakeholders communication, where our colleagues Natalia and Tina study the understanding of communication challenges between metrics team and their stakeholders, how the metrics are actually taking the next step farther into the decision processes. What they're studying is studying the environment in which the metrics are used. For example, they provide for providing insight, decisions, and early warnings. They study people and relationships, communication channels, both face-to-face and then mediated, like synchronous calls or asynchronous tickets. They study the artifacts, and they provide the solution for the companies. For example, what happens if a metric team doesn't get much feedback on the software measurements that they provide. For example, they propose the continuous integration like delivery of metrics, which is one of the improvements that one of the teams that they've studied is now implementing in one of the companies. That has not been part of their plan beforehand. And finally, what we recognize in our theme is that, of course, AI is the leading buzzword and the leading technology in the world today, and we have to start working with AI in a very different way. And AI is going to change the face of software engineering quite a lot. Smart bots, smart tools, smart environments are taking over, making the work of the developers a bit different. We talk about things like no code or low code, where almost everybody can create a simple app and start selling that, which means that in the essence, the programming task or software engineering tasks are moving to providing platforms and frameworks rather than providing ready products. That becomes the job of the integrators or low code companies. And with that, thank you very much for listening. I hope that you enjoyed the theme, and if you have any questions, I'll be very happy to answer that. Thank you.